Greetings, class. So today we are going to be comparing distributions, so looking at two distributions side by side, and then we're going to be talking about mean versus median based measures. So this is measures of center and spread. Once again, this is section 1.3 in your textbook. Feel free to follow along there if you would like to. So we are going to look at this example the entire class, so please make sure you get down those numbers. So the example says, suppose the class grades on the last quiz were the following grades. It has 85, 82, 75, 93, 34, yikes, 98, 87, 69, 90, and 86. So if we were given this question, the first part says find the 5-number summary. Well, we remember the 5-number summary is the min, Q1, the median, Q3, and the max. And we learned last class that our calculator has a great way to help us find those. We're going to talk about that in a minute. The second question says, how can we describe the center? So our calculator has a lot of tools that we can use. So we went through these steps last class. I have some screenshots here. We press stat and then edit to get to our list function. We typed in all the values in our list. Then we pressed stat again, went over to calc, and we wanted one var stats, which stands for one variable statistics. From there, if we had a new calculator, we typed in L1, which was second, then the button 1. On the old calculator, we typed in L1 after the one var stats by pressing second, then 1. So once we did those calculator steps, we got here, and it gave us the 5-number summary when we scrolled down, and it also gave us the mean and the standard deviation up here. We're really going to focus about the mean and standard deviation next chapter, but right now, the standard deviation is that SX1, and we round it to 2 decimal places. But we wanted the 5-number summary. That was question 1, or part A of the question. So I would record these 5 numbers, the min, Q1, median, Q3, and maximum for that part of the question. The second question says, how can we describe the center? So notice this is the same example we've been working with, but it's asking for us to talk about the center. And we said the center was the mean and the median. So we're going to break these two items down so we can find out how we can calculate these by hand or with a calculator. So just to review, the mean is the most common and the assumed measure of center. It's called the average. We hear that a lot. You want to know what the average is of something. The mean we notate as this. This is our notation for mean. Make sure you get that notation down, that this is the mean, and we call it X bar because it's X with a little bar above it. We're super creative here in stats class. So X bar is my mean, and your calculator gives you X bar. It's the first thing that pops up in one variable statistics. So the mean from the quiz grades would be a 79.9. But we had that value of 34 in the quiz grades, and that 34 is really bringing my mean down. If you look back at the data set, a lot of the data points are above 79.9. In fact, almost all of them are above 79.9. So this is the same information. You don't need to copy that. But if we wanted to remove the outlier, there was that 34 in there, and if I wanted to take that value away and say, what would be the mean if I removed the outlier? So I deleted the 34 from one var stats, when I recalculated it, the average is 85. So just by removing one value, my mean increased by over 5 points. It jumped up to an 85 when I removed that value of 34. So this brings us to key point number 1. The mean is not a resistant measure of center, meaning it does not resist well to change or to really high or really low values. So I made up this little fun rhyme. I say we can make the mean mean what we want it to mean. Meaning, no pun intended, if I have one outlier can drastically change the mean, or x bar. One outlier can drastically change the mean because we can make the mean mean what we want it to mean. Which brings us to the median. So the median, we said, is the midpoint of a distribution. If I lined everything up in increasing order, the median would be the middle. So the median from the quiz grades was 85.5. We got that doing 1-var stats in our calculator. Well, what if I wanted to do the same thing? What if I removed that 34 again and recalculated the median without that value? Well, the median only changes to 86. So by removing one value, my median only changed 0.5. The mean changed over 5 whole points. The median only changed a little bit. So that's key point number 2. The median is more resistant because outliers do not easily impact it. And that makes sense because if I line every number up, even if I have one really high value or one really low value, it's not going to change my median that much. I'm just getting rid of one data point on the end as opposed to totally taking it out of the average. So in stats, we say the median is more resistant because outliers do not easily impact it. So which measure should we choose? If I'm looking at a data set, how do I know whether I should use the median or the mean? So the first thing we do is graph the distribution. You always want to graph it or look at 5-number summary first. Ooh, sloppy handwriting. Look at the 5-number summary first. If you have a skewed distribution, meaning it looks something like this or it looks something like this, if you have visible outliers, like that 34 in my data set, you want to use the range and IQR to describe the spread and the median to describe the center. So once again, if you have a skewed distribution, you want to use the median for center and the IQR and range for spread. Shape and outliers are the same. If you have a roughly symmetric distribution, so if you have a distribution that looks like this, you want to use the mean. If you have no apparent outliers, you can use the mean. And we're going to talk a lot about this soon, but you want to use the standard deviation or the SX on the calculator for spread. So remember, the SX is just a couple below X bar or the mean. So if you have a skewed distribution, median, roughly symmetric, the mean, or X bar and SX. So key point number 3, and this is what we just said, if a distribution is skewed or has outliers, use the median and IQR for measures of spread and center. So if it's skewed, remember skewed looks like this or like this, you want to use the median. Another question that you'll see a lot is where is the mean relative to the median? So make sure you get these drawings down. These three drawings, make sure you get these. If you have a symmetric distribution, the mean and the median are going to be equal to each other. This was actually in your B notes. The mean and the median are equal in a symmetric distribution. Symmetric distribution. If you have a skewed right distribution, meaning the right tail is longer, the mean is going to be higher because you have high outliers or high values pulling the mean up. If you have a couple high values, they're going to pull your average to be higher the same way the 34 did for the problem we've been using. That was a skewed left distribution, and the mean was lower than the median. The mean was 79.9, where the median was 85.5 in the warm-up, or in the problems we've been using. So where's the mean relative to the median? Symmetric, they're the same. Right skew, the mean is higher. Left skew, the mean is lower. So the mean is always further out on the tail. That's a good way to remember it. So key point number 4, if a distribution is roughly symmetric, we can use the mean and standard deviation, which is SX in your calculator, for measures of spread and center. So that's a wrap. Depending on the data, we use either the mean or the median based measures of center and spread, graph the distribution first to determine which to use. Once again, this is section 1.3 of your textbook. Please go there for more examples and practice problems that you can reference throughout this chapter.